We have a box at rest on the floor and two boys are pulling on it with different forces acting at different angles. We want to find the graphical resultant of the two forces as well as the numeric resultant. The graphical method of finding resultants means that we are going to add the two forces together. We will do this by drawing them one after another, and our resultant will be from where we started until where we end. This coordinate axis will be our starting point. First we draw F1 on the coordinate axis. Notice that F1 is the same magnitude at the same angle. From the head of F1 we add F2. We draw a new coordinate axis from which to add F2. F2 is placed on the axis with the same magnitude and direction as it originally had. By adding these two vectors we get our resultant vector. The resultant goes from the beginning to the end. The angle theta is the angle that the vector makes with the original x-axis. If we had drawn F1 and F2 to scale, we could then place a ruler on R and measure the distance of the vector. This would be the size of the force of R. We could then put a protractor on the vector R and find the value for the angle theta. In part B, we will use the component method of solving for resultants. Both F1 and F2 are made up of components. These components will be added together to find the components of a resultant. Here is F1x and F1y. Here is F2x and F2y. Rx is made up of the sum of F1x plus F2x. Notice how when F2x is added to the head of F1x, it covers the horizontal distance from the y-axis to the end of the resultant. Ry is made up of the sum of F1y plus F2y. F1y plus F2y is the vertical distance from the x-axis to the end of the resultant. We can now see the vector triangle for our resultant. Here's the vector triangle for F1 and the vector triangle for F2. We are to use these triangles to solve for the resultant force. We are going to use the tabular method to solve for our resultants when summing our components, so we need to create a table for summing the forces in the x and the y. This is what our table will look like. We will have 3 rows. 1 row for each of our individual forces and 1 row for our resultant, which will be the sum of the individual force components. We also have 2 columns. These columns will be for our x and y components of each force. The first cell we will fill in is the x component for F1. Remember that the x component is equal to the resultant times the cosine of the angle. We then fill in the x component for F2. Rx is the sum of F1x plus F2x. Next we fill in the value for the y components. F1y is equal to F1 sine theta. Here is F2y. Ry is the sum of F1y plus F2y. Next we will draw a force triangle for the resultant. Since Rx and Ry are both positive, R is in the first quadrant. To solve for R, we use the Pythagorean theorem, substitute in our values for Rx and Ry, and find the magnitude of our resultant. We want to find the angle that our resultant acts at in the first quadrant, and we'll use tangent to do this. Substitute in our numbers, and find the direction of our resultant. Finally, we write out our answer in magnitude angle form. This is the same answer we would have gotten part A when using a ruler and a protractor.